Hello, this is Professor Salahat, and now we're gonna continue with homework 6, and we're gonna look at number 14. In number 14, it says find the critical values and rejection regions for the indicated t-test, and let's pay attention to this. It is a t-test, it's not a z-test. We know that we use t-tests when we are dealing with unknown population standard deviation. So keep that in mind. So let me go in here, and I'm going to use StatCrunch to find the critical values. And we learned how to find critical values with t-tests before. It's just now it's a matter of dealing with the problem from a different perspective. Again, when you have a t-test and when we deal with critical values, we go to stat. Then we're going to go to, let me make sure the volume is on. Yes. So I'm going to go to stat. Sorry. I suspected the volume is not on. We're going to go to stat, and we're going to go to calculators, and we're going to go down to T. This is for critical. Always for critical, you go calculators. Then we need to look at this. This is a right tail test. Automatically go to here and flip this to greater than to make it a right tail. Look at the shade. It's right shaded. Then after that, we're going to go to degree of freedom. Always degree of freedom is n minus 1. So n in our example here is 15. So we're going to put 14. And then we're going to fill the alpha in the last box, which is 0.01. And we hit compute. That's going to give us the 2 point. And again, we need only to the nearest thousand. So we only 3 places. So 624. And when you hit enter, you get the correct answer. The second part, it says determine the rejection region. Notice that the rejection region is the red shaded area here. Notice this area is greater than. So we have this Z critical, and let me just show that in my drawing in there. It looks like this. Here is our 2.624, and this region here is the rejection region. So the rejection region here is anything greater than, anything bigger or greater than the 2.62. So in this case, when I say anything, any t greater than 2.624. So the answer will be here is C, and we put 2.624. Okay. And because again, we're going to use the same Z critical, the point is the first part A says less than, means to the left. This says in between. This says left or right. So no, we are just talking about right. So this is the correct answer. Move to the next one. In the next one here, this question actually consists of multi-parts. State whether the standardized test statistic T indicated or indicates that they should reject the null hypothesis, and explain. Now, notice one thing. We are given a fixed T critical. So let me point to this. Here's what we have. The T critical is a left. It's given in the picture. T0 or T critical is native 1.639. Then we are given, let me write this to the side here. We are given 4 choices. Choice A, choice B, choice C, choice D. We are given that the one in purple here is the T critical. The one we are given is the T statistic. So the T stat for part A is 1.653. For part B is 0. For part C is native 1.566. And the last one is native 1.688. It is very simple in here just to look back and say, okay, if you take this one and try to plug it back in, it's going to plug in here. So this is the rejection region. It's going to plug in above the rejection region. So in this case, we're not going to reject. So for the first one, for 1.653 for part A, fail to reject H note because the T is bigger. We're going to choose A. Okay. Now, fail to reject. Why we fail to reject again? Because the 1.53 fell in this region, where in this region we do not reject. We only reject in the left region. So the 1.5 something fell in here, so it fell into the region that we don't reject in. Fail to reject because T is bigger than. Okay, so check. Now let's go to the second one. I'm going to use a different color. What about T equal to 0? Notice that the 0 falls also here because this is native. The 0 falls to the right of the native. Again, for the 0, we fail to reject H note because the T in this case 0 is bigger than. So we're going to choose A again. Notice we're going to fail to reject. So it's going to be either A or B. But in this case, in B it says less. In A it says more. It is more. So we're going to check that answer. Now for part C, they tell you, okay, look at the number native, look at this number in here, which is native. Let me use a different color in here. So let me look at this one. The native 1 point, this is by the way native 1.566 is still native 1.566 is above native 1.639. Because native 1.566 is bigger than, remember those are two native numbers. So the native 1.639 is smaller than native 1.566. So in this case, still we're going to fail to reject because we are fail that the value is in the safe region. So in this case, we're going to say fail to reject H note because, again, we're going to choose C because the native 1.566 given here is bigger than the 1.639. Finally, let's go to the last one, which is this one here. And let me highlight that with this color. Now this native 1.688 is finally under. And therefore, we're going to continue here and we're going to go to 1.688 is smaller than 1.639. Therefore, we're going to reject H note because it is smaller. So it is, the answer is C because it is smaller. Question after that is testing and claim. So the question after that is number 16. In number 16, they tell us a used car dealer says that the mean price, so this is again, we're going to start with this, H note and HA. Both of them is going to be about a mean. And the reason why it's a mean because they said the mean price. So they're talking about the mean. So this car dealer claims that the mean price of a 3-year-old sports utility vehicle is, notice that they said is means equal, is $21,000. And that is his claim. So I'm going to write the word claim in there. Now remember, if he said is not, then we're going to put is not in there. And we're going to write the claim, the word claim, we're going to write it in here. In this case, we don't do that because the claim is the is and it's not the is not. Now suppose, oh, I'm sorry. We have to be careful in here. I rushed a little bit. I should have read this one. You suspect this claim is incorrect. Okay. So you suspect the claim is incorrect. And find a random sample. So this random sample of, this is N, 21 vehicle. I'm going to come back and comment on this in a minute. 21 similar vehicles has a mean that is X bar of 21,520. That's what they tell us. And a standard. Look at this. And a standard deviation. Look in here. They did not tell me and a population. It's missing the word population standard deviation. Therefore, this is S, which is the sample standard deviation, which is 1925. And that is telling me to use the t-test. Automatically, if S is given, you use the t-test. Now, if a population standard deviation is given, you use a z-test. Now, Is there enough evidence to reject the claim? Okay. So let's see. Now, which one is the statement in here? Now, based on this, the statement will be part C. Now, remember, it depends on the story in here. You can say this is the dealer's claim, or you can say I'm going to start with my claim, because if you suspect, you create your own claim. But let's stick with the dealer's claim. Now, if we stick with the dealer's claim and it's equal to, let's check, and it's correct. Now, let's find the T0. Notice that T0 is the same as T critical. How do you find T critical? You're going to go to Stat, Calculators, and you're going to go to T. And notice that because our test has not equal in it, let me emphasize on this. Because our test has HA has not equal in it, it is between. Because we'll have two tails. And it's going to look like this. X is going to be between two numbers, and it's equal. And in the last box, you're going to put 1 minus alpha. In this case, our alpha in the problem here is 10%. So we're going to put 1 minus 10%. So again, I'm going to pull StatCrunch. I'm going to follow those steps that I put on the side. I'm going to go to Stat. And I forgot to put something else. I'm going to add it, which is degree of freedom, T-stat, one sample. I'm sorry, I'm going to go Stat, Calculators, and a T. And we have to come in here, and we have to press the between. And I said I forget something, and I have to put it in there, and that is degree of freedom. Degree of freedom is always n minus 1. So if we look back at our problem, they tell us in our problem here, n is 21. So in this case, it's going to be 20. And in the last box, we're going to go in there and put 1 minus the alpha, which is 0.10. So when we put all of this, it's going to give us the Z critical to be two of them. One of them is negative 1.7247, comma, the other one is 1.7247. Notice that there are two criticals. One is going to be in here on the right, and one is going to be on the left. So let me put this down, come back in here. So it says in here, use a comma to separate answers. So, and we want to 3 decimal places, is going to be negative 1.725, comma, and 1.725. Don't just put a space in there. Click on your keyboard, the comma key, and put them like that, and it should be okay. The next step will be, and let me pull the StatCrunch again. Look at the picture. Now, the rejection region actually is 2, not 1. It is the left side in here and the right side in there. Let me put it into this. It looks nicer. Here's the picture. There is 2 critical values. This is the first one, and this is the second one. So this is a T critical, and this is T critical. Notice that in here they call it T0, T0. It doesn't matter. Now we have 2 rejections regions, this one and this one. This one is less, and this one is more. So we're going to choose here, B. Don't choose the C, because C is talking about between. We're not talking about between. We're talking about T is less than the native, which is negative 1.725, and the other one, which is the T, is greater than 1.725. Now, when you put it this way, you're going to get the correct answer. Now, the next step will be find the standardized test statistic. To find the standardized test statistic, you're going to go Stat, and you're going to go to T stats. And again, remember, sigma is not known, is unknown. That's the reason why T stat. One sample with summary, because the summary is given in this case. Then after that, when we go in there, we fill the 3 boxes that we are given, and then we circle the test, and we fill H0 and HA as given in the problem. Then after that, we compute. So let's just do this here. Here's StatCrunch. We're going to go to stat. We're going to go to tstat, one sample with summary. And now we're going to fill the sample mean. Notice that the sample mean was 21,520. 21,520. And the standard deviation given is 1925. Sample size given, in this case, they told us 21 similar vehicles. So they talk about 20 vehicles in here, or 21, sorry. And the test is as in C here. We checked it. So as in C, equal to 21,000, 1, 2, 3, zeros or not equal to 21,000, and hit compute. And that's going to give us the t-stat. Here's the t-stat. So we need that t-stat to do decimal place is going to be 1.24. And again, so we need to pull that or put that in there, 1.24. Hit enter, and it's the correct answer. Now, this is the time where I need to keep this in mind. The question in here, decide what to do. Notice one thing, or many things in this case. The first thing is, let's go back to our statement. We wrote it down somewhere in there. Here. Now, if you look at our statement, let me just erase this and rewrite it again. This is our claim. If you look at our statement in here, we got a p-value equal to, and look at the table here. Here's the p-value, 0.2301, 0.2301. And alpha is given in the problem, and it is 10%. We know that this p-value is bigger than alpha. If the p-value is bigger than alpha, then automatically fail to reject H-naught. So H-naught is not rejected. And notice one thing else, that if H-naught is not rejected, then therefore the claim is not rejected, because H-naught is the same as the claim. So in this case, we're going to go down in here and say, okay, fail to reject H-naught, which is A. Don't use B or C because they are reject, and D is fail to reject H-naught. So we're going to fail to reject H-naught. Now, question is, why? Now, the question is because the p-value is bigger than alpha. But in this case, they say, okay, let's talk about the test statistic and the rejection region. Notice that if you fail to reject H-naught, it means that the t-stat did not fall. It didn't go here. It didn't go there. It did not go here or there. It went somewhere in there. So in this case, we're going to fail to reject H-naught because the test statistic is not in the rejection region, or because the test statistic is in the rejection region. Notice that. You fail to reject because it is not in the rejection region. So we're going to choose A. Okay. Now the last part of the problem telling us, okay, if you are failing to reject H-naught, what happens to the claim? Notice that we said this earlier. If you fail to reject H-naught, you are failing to reject the claim. It's the same because H-naught happened to be the claim. So we're going to come in here and say, okay, at the 10% level of significance, there is not sufficient evidence to reject the claim. That is number one, or A. In part B, it says there is not sufficient evidence to reject the claim. Remember, I think it is, okay. What is the difference between, let's look at C. C says there is sufficient evidence to reject the claim, which is not true. And in D, it says there is sufficient evidence to reject the claim, which is, I'm sorry, C is false. And D is also false because it says reject the claim, reject the claim. We're not rejecting the claim. So we have to choose between A and B. At the 10% level of significance, there is not sufficient evidence to reject the claim that the mean price, remember in A it says the mean price is 21. And part B says the mean price is not 21. Look at the claim. The claim says is. It doesn't say is not. So we're going to choose the A. The difference between A and B is the word not in the second B. Okay? So the claim says is. It didn't say is not. Look at the problem. The claim is saying is here. So when we check, I'm sorry, I said A and I checked B, sorry. When we check, we get the correct answer. I don't know why I said A and I left that check on B. So this is the answer to number 16. Number 17, in number 17, let's look at the problem. Again, automatically we assume it is H naught and HA because we're dealing with testing claims in here. The question is, what are we trying to test in here? Test the claim that the mean, so automatically it's a mean problem. So I can come in here and say, this problem is about a mean, mu. Notice that it's nothing else, nothing of those but the mean. And so let's continue now. The mean amount of carbon monoxide in the air in the US cities is less than. Remember, they use the term less than. We know that less than goes with the bottom. If less than goes with the bottom, greater than or equal goes in the top. So let's come in here. It says greater than or equal to here, and it's going to be less than in there. Here's the less. Less than who? Less than 2.32. So 2.32, 2.32. So the 2.32 goes into the last box. 2.32, and in the next box is going to be 2.32. So that's how we fill this. Oops, where is the 2 here? 2. Okay. Now, which one is the claim? Look, let's look again. The claim is that the mean is less. So less is this. So the claim is the second. This is our claim. The claim is HA. HA, which is alternative hypothesis. That is the claim. The next step will be use technology to find the critical values. Notice in the problem here, I need to know, do I need to use a Z or a T? Now we are in search for the standard deviation. When we look and read the problem here, it says it was found that the mean amount of carbon monoxide in the air for the random sample of 66 cities is 2.38. So again, here they tell us that the sample size is 66 cities, and they said that the sample mean is, which is X bar, is 2.38. And remember here, and the standard deviation. It is missing, and they are not talking about population standard deviation because there is no population here. They're talking about the standard deviation. In other words, they're talking about sample, which is 2.12. If it's an S, automatically it's a T. So how do you find the critical T? We go to StatCrunch. And don't forget one thing in here before I leave this. I need to know alpha, and alpha in the problem is given to be 0.01. It is somewhere in there. Okay, so I know everything I need. Now I know this is, I know automatically that this is a left tail test. And the reason I know, because if I look at HA, it has a less. A less is an indication of a left tail test. So this is a left tail test. Now the question is to find the Z, or I'm sorry, the Z, I said, the T0 or the T critical. So to find the T0 or T critical, I'm going to use StatCrunch as follows. Stat, calculators, T. Notice that this is only a left tail test. So I'm going to make sure it's a left tail, which is here. Then after that, the degree of freedom is in this problem, because N is 66, the degree of freedom is going to be 65. And alpha goes into the last box, which is 0.01. And if I do all this math correctly, this T critical is going to be negative 2.38509. So let's go and see how much or how many digits we need. And I'll go again, there is only one of them, so I don't need commas, I don't need anything. They want The answer to 2 decimal places is going to be 39. So when I put 39, it's the correct answer. The next step will be look at this problem here and tell me which one is the correct answer. I know it is a left tail test. B is a match. A is a right tail test. C and D is not the correct answers because they talk about, actually D is not correct at all because they talk about confidence interval. D talks about two tail tests. So C is a left tail test. Check the answer. I'm sorry, B. B, let me repeat. B is a left tail test. Now find the test statistic. To find the test statistic, this is what we do with StatCrunch. I have the data next to me here. I go to stat, I go to tstat, one sample with summary, and I fill the mean. Again, the data is in here, so I'm going to fill from there. I fill the mean, sample mean, which is 2.38, the standard deviation 2.12, the sample size is 66. Notice they ask for sample size, they're not asking for degree of freedom. And the test to match, here is a test in front of me. Notice this number is 2.32. Notice with StatCrunch, it doesn't allow you to put greater than equal. Okay, just keep it equal, but make sure A is matching. A is going to be matching, which is less than, and hit compute, and you get the answer. Let me move this in here. We're going to get the answer we're looking for the T statistic here. It is 0.2, and how many we need? 2 places. It's going to be 2, 3. So when you check, it is correct. The next thing is decide what to do. Okay, so we're going to decide on what to do here. So let me put this up here. Remember, this is the test statistic. Or I'm sorry, the critical. And the test statistic T, we found it is equal to 0.23. Notice that the 0.23, it doesn't fall under, it falls somewhere above, somewhere in here. Because this is a native 2.3. So it falls into the safe region. So in this case, what we do in here, if it falls above the rejection region, we're going to fail to reject H note because the standardized test statistic is not in the rejection region. Remember, it's not in the red zone in here. If it falls into the red zone, then you're going to reject H note. In this case, it did not fall into the reject zone, so you're not going to reject it. Now, this is for H note. So now let's go back to our problem. Here's our problem. I need to write a few things in here. Now, we took a decision here to do not reject. In other words, fail to reject H note. Automatically, the opposite will happen to HA. HA will be rejected. So reject HA. Notice if I shrink the screen a little bit in here, notice that what happened in this case is you are, let me clear this. We don't need, oops. Maybe I need to. Okay, so let me rewrite this. Here's H note. This is mu greater than or equal. This is mu less than 2.32, and this is our claim. So what happened is when we fail to reject H note, we're going to reject HA. And if you reject HA, automatically you are rejecting the claim because HA happened to be the claim. So here, there is enough evidence at the, remember, the level in there is going to be what? 1%. Remember, this is 0.01. When you change it to decimal to a percent, is going to be 1%. Now, we are talking about the claim. Okay. Now let's start from the back. The claim. What is the claim saying? The claim is saying that the mean amount of carbon monoxide in the air in U.S. cities is what? The mean is saying is what? Here it is. What it's saying is less than. This is what the claim is saying. So this is less than How many? 2.32. That is what the claim is saying. Okay, so now what should I do? There is enough evidence to reject the claim? Yes or no? And the answer, yeah, we said that. We said, look at the claim. There is enough evidence to reject the claim. So there is enough evidence to, at this level of significance, which is 1%, to reject the claim. Okay, because we said reject the claim, so there is enough evidence at the 1% level of significance to reject the claim. Sorry about this disruption. Okay, let me go back to my homework. So we're going to check the answer. Oops. Now, I think the book chose the other way around. Let me go back in here. For some reason, I lost track. I lost my computer, by the way. So here's my problem. I think the book is trying to look at this from a different point of view. Now, remember, in this problem in here, the people who entered this is a correct answer, perfectly correct answer. But the people who put the answer in there, they wanted a different way to describe this. Now, we said in here there is enough evidence to reject the claim. But you can say it differently. You can say there is not enough evidence to support the claim. This is equivalent to there is enough evidence to reject the claim. If you check the answer, it's going to give you the correct answer. So that's a different way to say things. Now, I don't know why they didn't allow those two options in the question. But again, if there is not enough evidence to support, then there is enough evidence to reject. They are equivalent statements. So I'm going to stop in here, and I fixed the problem that happened to my computer just a second ago.